Okay, today we're going to talk about how we solve quadratics by another method when we learn how to solve them by factoring. Today we're going to learn how to solve quadratics by using what's known as completing the square. So it kind of deals with what we talked about with factoring, and I'll show you how that connects in just a moment here. But let's say we have, and get the idea of what completing the square means. So let's say we have this equation x squared plus 6x plus something. We want to know what that something is in order to make this a factorable equation. So if we kind of get this idea of our square, so I want to get x squared plus 6x plus something. We'll call that our c value. And we want that to be factored in a perfect square trinomial. So how do I do that? Well, I know that one term has to be x squared. And for this to work out as a perfect square, I know that these two have to be the same, 3x and 3x, because we have to split up our second term evenly. So how do I factor this? Well, how do I get x squared? It's got to be x times x. And how do I get 3x? Well, it's got to be 3 times x. 3 times x. If that's the case, 3 times 3 is 9. So our c value would have to be 9, and it has to be x plus 3 2 times. So if we go back to what we were looking at here, this would have to be 9 to make this factorable, because then we could say x plus 3 squared. So then if we had another one, x squared plus 10x plus what would make this factorable? Well, if I have to split this up evenly, that would be 5x and 5x. So if I want to do that, so I reset my equation and take a look using the box method, but I have x squared plus 10x plus what? So I know x times x will give me the x squared. I know these would have to each be 5x, so x plus 5 and x plus 5, as long as my c value is 5 times 5 is 25. So in this case, my c value would be 25. So if c is 25, that could be x plus 5 squared. And what would it be if I had x squared plus 20x plus what value? Well, that value would have to be, maybe you can guess it, would have to be 100. It would be x plus 10 squared. So maybe you're seeing the connection. So how do we go from b to c to the number in parentheses? How do I go from this b value, when it's x squared plus bx plus c? How do I figure out what this missing c value has to be, and then how do I figure out what this has to be in parentheses? So that's kind of what we're trying to figure out here, and you can kind of see up here how we do that. Well, if I know the b term, I just divide it by 2, and then I square it to get my c term. And then the number in parentheses is just half of b, because we're just splitting that into 2 equal parts. If I want to get 10x, I split it in 2 equal parts. So my factored part is going to be half of that. The c is going to be squared. So that's how we complete the square. So for instance, to find my c value, that's going to make this a perfect square trinomial. I need to take half of 38, which is negative 19, and then I square that. So it's going to be x squared minus 38x plus whatever 19 squared is. And if I don't know, I can check my calculator. 19 squared is 361. Okay, so why don't you try figuring out the c values for the rest of these on this page, and when you're ready, restart the video. Okay, so notice once we find our c value for this one, divide our b by 2, and then square it to get 256. Here, fractions aren't a problem. Just take negative 5/3, divide it by 2. And remember, when you divide by 2, it's multiplying by a half. So that gives us negative 5/6. And then we square that. And when we square it, negative becomes positive, so positive 25 over 36. C value is a positive 144, number 4. 49 for 5 and 4 100ths, or 2/50ths if I want to simplify it down for number 6. So that's the basics. Got to understand how to find the c value if we want to complete the square. Next, I'll show you how we can use that to help us solve an equation. Okay, so the way we can do this is it helps us if we don't want to factor, if we don't want to try to figure out what the factors are. So we just kick out the c term. So I'm going to add 3 to both sides to get rid of my c term. I'm going to find a new c term. Find one that gives me a perfect square trinomial, so I don't have to worry about factoring. So plus my c value. That's going to equal 3. So now I come up with my own new c term, and if I divide 2 by 2, it gives me 1. Squared, it's going to be 1. So my new c value is going to be 1. So instead of c, I'm going to add 1. And if I add 1 to one side of the equation, well, hopefully you remember that I should add 1 to the other side, because I can't just add a number without changing the whole equation. So if I add 1 to both sides, that'll remain true. So now that I have this perfect square trinomial made, its factored form is a plus 1 squared. A plus 1 times a plus 1. That's going to equal 4. So now that I have that, how do I get rid of a square? I can take the square root. So a plus 1 equals square root of 4, and plus or minus square root of 4. And since square root of 4 is 2, well, I know a plus 1 equals plus or minus 2. And then I just need to subtract 1 from both sides. So when I subtract 1, I have a is equal to negative 1 plus or minus 2. So a would be equal to, well, negative 1 plus 2 is positive 1. And negative 1 minus 2 is negative 3. So a would be equal to 1 or negative 3. Okay, so that's how we use the completing the square method to help us. It saves a little bit of time because you don't have to come up with your factors. And then we can just take square roots when we're solving the equation. So let's solve number 2 together, and then I'll let you try 3 and 4 on your own. I'll use a different color pen here. So when we have this first example, I'm just going to add 8, get rid of my c term, so I can come up with a new c term of my own. So a squared minus 2a plus my c value is going to equal 8. Once I decide what my c value is, I'll plug it in there. So I come up with my c value by figuring out what's going to make this a perfect square trinomial. So I'm going to add 1 in there. If I add 1 to the left side, I have to add 1 to the right. Then I'll factor this down. Well, my perfect square trinomial is a minus 1 squared. That's going to equal 9. I'll take the square root of both sides, so a minus 1 will equal plus or minus the square root of 9. Square root of 9 is 3, so a minus 1 equals plus or minus 3. And so if I add 1 to both sides, I know a equals 1 plus or minus 3. So a will equal, well, 1 plus 3 is 4, and 1 minus 3 is negative 2. So that is completing the square method. Why don't you pause the video and try 3 and 4 and restart it when you're ready to take a look at an explanation. So let's take a look at number 3. I added 22 to both sides to get rid of my c value, and I need to find a new one now. So I divided by 2 to get 8 and squared it to get 64. Added 64 to both sides. And then I factored my perfect square trinomial. It's bp plus 8 squared was 86. Took the square root. Now the square root of 86 is not a perfect square. So I just left it for now. I subtracted 8. So negative 8 plus or minus the square root of 86. This would be the exact solution. If you want to approximate it and approximate the square root of 86, we'd have 1.3 or negative 17.3. So either way would be acceptable. If the problem is asking you to approximate it, you could type that in your calculator and get an approximation. Number 4, I subtracted 12. Found my c value to be 16, so I added 16 to both sides. And I got k plus 4 squared equals 4. Square root of 4 is 2, so I subtracted 4 from both sides to get k by itself. So negative 4 plus 2, which is negative 2, and then negative 4 minus 2, which is negative 6. Okay, so those are examples of ways that we can use the completing the square method. Here is a final way that we can do that. We've got a word problem that we can set up. It says we want to use chalkboard paint to create chalkboard on a door. We want the chalkboard to have a uniform border. So we want to know if we have enough chalkboard paint to cover 6 square feet, or we have enough to cover 6 square feet. So we want to find the width of the border to the nearest inch. So how are we going to do that? So the first thing we should do is just figure out what we know. We know that we have 6 square feet of paint, and that's what we want to figure out how to use this chalkboard paint. Then we need to figure out how much area we need to cover. So we need this area, length times width. So if I know the total width of 3, and I know each side has x on it. So if I take this whole area of 3 and subtract off 2 x's, that'll give me my width. I'm going to multiply that by the height. I know the total height is 7. And once again, I have an x on the top and x on the bottom to create a uniform border. So 7 minus 2x. Okay, and that's going to create equation length times width will equal a total of 6. So now if we distribute, so we get 21 minus 6x minus 14x plus 4x squared equals 6. Now I've got a pretty complex quadratic equation. Let's rearrange terms and combine. So I'll put my x term at the beginning, my 4x squared. Combine negative 6x and negative 14x to make negative 20x. And then I put the positive 21 at the end. That equals 6. So now, in order to make this work, let's get rid of our c term so we can find our perfect square trinomial. And now we have 4x squared minus 20x equals negative 15. Now we got to find out what our c term is. But before we do that, you might be wondering, well, Mr. Hokemuth, we haven't done a problem like this before. There's a value here in the a term. All the other problems we've looked at, they haven't had any values with the a term. So let's just get rid of it. Divide it by 4. If we divide by our a term on both sides of the equation, we're not changing the equation. But we got to remember to keep in mind that if we divide, we also have to divide this b term as well. So it's going to be minus 5x. So x squared minus 5x once we divide by 4, and we got to find our new c value. That's going to equal negative 15 over 4. So now our c value, remember we take this negative 5 and divide it by 2. It'll be negative 5 over 2. And then when we square that, will give us 25 over 4. So we'll add 25 over 4 to both sides of our equation. So plus 25 over 4. And now we've got to simplify. So if I factor this expression down, I get x minus 5 over 2 squared, because that's our perfect square trinomial. And that's going to equal 10 over 4, which I know will simplify as 5 halves. So I'll just simplify that right away. And then we take the square root, so x minus 5 halves equals plus or minus square root of 5 halves. And so I add 5 halves to both sides, and I'll have x will equal 5 halves plus or minus the square root of 5 halves. And that would be our exact expression. If we want to simplify it, now we're just going to have to use our calculator to give an approximated value. So 5 halves plus the square root of 5/2 gives us a value of approximately 4 point, what's it say, to the nearest inch? So 4.1, so it'd be about 4 inches. And then the other value, and actually we're measuring in feet, aren't we? So about 4 feet, 4.1 feet. Make sure we keep our units correct. So since all our units are in feet, this is about 4.1 feet. Or if we take 5/2 and we subtract the square root of 5/2, that comes to approximately 0.9 feet. So as we take a look at these values, we got to determine which one makes sense. So obviously, if I have 4 feet border on each side, that's not going to work for the door because it takes up more than the door. So that's not going to work. So if we have 0.9 feet, we still have enough room for the chalkboard border. So 0.9 feet, convert that to inches, so multiply by 12. We'll have about 11 inches for our value. So a little bit of problem solving, got to set up an equation. We can use our completing the square method and then use that to interpret our solution and find out what works. So you learned a new method today, completing the square. You found out how it's similar to factoring and especially those perfect square trinomials. So we'll do some practice with that, and any questions I'll help you in class.